Hi, it's Mrs. Moss here, and we're going to start talking today about meteorology. Now, meteorology is the study of weather. It is not the study of meteors. And we actually already began our discussion of meteorology when we were learning about energy, because energy is the driving force behind meteorology. So when we talk about meteorology and studying weather, we need to look at the difference between weather and climate. The difference between the two is that weather is a short-term condition of the atmosphere. It's when you look outside and you see what's happening now. It's daily differences in temperature from day to day, moisture, air pressure, and wind. Climate, on the other hand, is a long-term condition, and we can trace climate is basically the weather patterns over a long stretch of time. So when we talk about meteorology, we have specific weather variables that we look at. And actually, you'll hear these weather variables reported by your meteorologist or weatherman that you see on TV. Let's start with humidity. What is humidity? Well, humidity is the moisture content in the air. And there are two ways to measure humidity. We look at the absolute humidity, which is the actual amount of moisture in the air. It's the number of molecules or grams that are in the air. For example, this parcel of air has 10 grams of water vapor. We also look at humidity in terms of relative humidity, and that's where more often you'll hear the term relative humidity on your news report. And the relative humidity is the percentage of saturation in the air. Now when we talk about the word saturation, we're talking about the water content. So when it's saturated, that's the relative humidity. So let's talk about that a little bit. 50% humidity means that the air is holding half of the amount of water that it is capable of holding. Whereas 100% humidity tells you that the air is fully saturated and it cannot hold any more. It is filled to capacity at 100%. So let's talk about this visually. We have parcel A and parcel B. Now parcel A, you see the humidity level goes up to this line. Parcel B, the humidity level goes up to this line. So let's give a percentage. About what percentage of parcel A could we say is the relative humidity? We would say this would be about 50% because it can still hold another 50% of water vapor. It's holding half of what it can fulfill. Whereas if we look at parcel B, well, parcel B is at 80% relative humidity. 80% of this is filled and it can hold still 20% of water vapor left. So that's what we're talking about when we talk about relative humidity. It's a percentage of what it is holding. Here's relative humidity and the rain. Now, as the relative humidity of the air increases, the chance of precipitation will also increase, which makes sense. If we go back to this picture, as we're increasing the amount of water vapor the air is capable of holding, there is more likely of a chance that rain will occur. And 90% humidity would then mean we have a very, very high chance of rain. Whereas if we gave a lower percentage, like 10%, then it would be a less chance of rain. So what is the dew point temperature? Well, this is a temperature that you may not be familiar with. You will be soon. But if you listen to that same weatherman who's reporting about relative humidity, there's a very good chance you'll hear him use the term dew point temperature as well. The dew point temperature is just that. It's the point at which dew can form. Dew is a condensation process, so it's the temperature at which air is holding the maximum amount of water vapor it can hold, and that's called the dew point temperature. So when air reaches the dew point temperature, it is saturated. It can't hold any more moisture. And the dew point temperature and the relative humidity go together quite often. And they're used, the tool that we use to determine the relative humidity and the dew point temperature is known as a sling psychrometer. We may be using them in class. So let's take a look at this little comic, okay? It says the dew point temperature. Now, if we look over here, we have a temperature, an air temperature of 53 degrees. We have a dew point temperature of 51 degrees. And we hear the water vapor saying we're almost there. Now remember, when water is in its vapor form, we can't see it, so nothing is in the picture yet. In the second box, we have the temperature at 52, and now it's at 51. Dew point remains the same. So now they're saying, get ready. And if you look here, what happens? The temperature drops to 51 degrees, which is the dew point temperature. Now all of a sudden, we see dew or condensation formed. So it says, let's do it. Whee! Okay, so here's what you want to take from this comic. When the air temperature reaches the dew point temperature, the relative humidity is at 100% and precipitation occurs. Write this down, star it with big asterisks, make circles, anything that you can to remind yourself of this fact. This is a crucial fact when we look at meteorology. Now you're going to open your reference table to page 12. And what you notice is there are two charts. There's a dew point temperature chart and there's a relative humidity temperature chart. Now, both of those look identical, but there are some subtle differences. The first one being that the title, the dew point temperature, where is my cursor? There it is. Dew point temperature. It is a temperature, so it is in degrees Celsius. You'll notice that the relative humidity, because it's a percentage, and that's what we use as the definition, it is in the percentage. So the numbers are different, but they're actually used in the same manner. So when we said we have a sling psychrometer, we use the two temperatures from the sling psychrometer. One will be a wet bulb and one will be a dry bulb. And we take the difference between the wet and dry bulb. Notice this word here on the x-axis. It is the difference between the wet and dry bulb. You subtract those two numbers and then you use that number along the top. Then you take the dry bulb temperature, which is also known as your air temperature, and you find that along the bottom, along the y-axis. So we match the difference with the dry bulb temperature and we get our dew point temperature. Where they meet is the dew point. So let's try one. In this box it asks, what is the dew point temperature if the dry bulb is 12 degrees Celsius and the wet bulb is 5 degrees Celsius? So we would have to determine what is the difference between them. That would be 7, and we go up to 7 at the top. We then look at 12, which would be along here, and we go across until we get to 7, which is right here. So we see that the dew point temperature would be -5 degrees Celsius. Okay, so again, let's just check. And yes, because the dry is 12, the wet is 5, the difference is 7. So we have to look, and it brings us to -5 degrees Celsius. So now let's look down at the relative humidity chart. We're going to do the same thing that we did with our dew point temperature chart. If we have a dry bulb temperature of -6 degrees Celsius and a wet bulb temperature of -3 degrees Celsius, that brings us a difference of 3. Okay, so then we go down to the -6 degrees Celsius dry bulb temperature and we go across to the 3, and we see that the relative humidity would be 20%. Okay, so for now, that's where we're going to end. We'll get more practice with this when we're in class. But the first few weather variables that we looked at today, to recap, are dew point temperature and relative humidity. We'll continue on with more weather variables in our next video. Take care. Have a great day.